Hello everyone, I am Ranjit J, Assistant Professor in Department of Information Science Engineering, SJB Institute of Technology. In this semester, I'll be handling analog and digital electronics for you all. In this subject, we'll be having totally 5 models. Very first model, we will start with learning about JFETs, MOSFETs and operational amplifiers. Next, we'll be learning about basic gates and different kind of wave shaping circuits. And next, at last, we'll be learning about flip-flops in this subject. If you want to learn this analog and digital electronics, one should have a strong basics on basic electronics as well as logic gates. So here, if you want to learn this subject, you will be having a lot of advantages. In the future, if you are dreaming about to become an embedded system engineer as well as a hardware engineer, this subject really teaches a strong basics about what are the different components you will use for the construction of computer. Thank you very much.
Hello students, today we are doing the demonstration of synchronous up counter using JK flip-flop IC. So this is the digital electronic experiment, so number 8. So as the name tells, synchronous up counter, so it is going to count the number of values in the increasing order. So synchronous indicates there will be a clock for all the stages of flip-flop. So clock will be separately provided for all the stages of flip-flop. So earlier we saw asynchronous counter, so where the output of the first stage of the flip-flop was given to the next flip-flop clock. But here synchronous up counter, the clock is provided simultaneously. So the components that is required for this experiment are 7476 IC, 7476 IC 7408, trainer kit and patch cards. So in this the pin diagram for 7476 is as shown. So it is a 16 pin IC. So we require we can perform 2 flip-flops. We can make use of 2 flip-flops in this 7476 IC. So since we need 3 flip-flops, so we need 2 7476 IC, and we have to conduct this experiment using JK flip-flop. So JK flip-flop IC is 7476 and the truth table is as shown. So before getting into the circuit, we need to design first for mod 6. So the state diagram for mod 6 is as shown. So state diagram indicates, again, if the value of n is 6, so how much does the counter run? Counter runs from 0 to 5. So first it will go to 0, then 1, then 2, 3, 4, 5 and again back to 0. So since it is a up counter, it is going to continue the increasing loop 0 to 5. And again here also, in order to get the inputs for the JK flip-flop, we need to solve using K-map. So the values for the K-map is obtained from this truth table, where we have the clock, present state, that is QA, QB, QC, next state QA plus 1, QB plus 1, QC plus 1. So for since we are designing the circuit for mod 6, after 6th row, that is after the 6th clock pulse, next must be don't care. Next values of the next state must be don't care completely. And the present state, if it is 0, next state will be obviously 1. So this has to be written from the diagram. If it is 1, next state will be 2. If it is present state is 2, next state will be 3 and so on. Only for 5, that is since we are counting from 0 to 5, when the present state is 5, the next state must be 0. Okay. So after writing present state and next state from the truth table of JK flip-flop, we need to fill this JA, KA, JB, KB, JC, KC columns, and these values column wise according to respective JA, KA, we need to fill in the K-map and get the expression. So according to this, we have got the values as shown, and this will be the circuit. So in the circuit, you can see there are 3 flip-flops A, B, C, and we need two 7476 ICs, and also we need to connect AND gates. So with one IC we can connect it. So first, initially you need to see that the clock connections for synchronous up counter, the clock is provided separately to each and every stage of the flip-flop that is present, and even preset and clear must be kept high by connecting it to the input switch. So the outputs are given to the QA, QB, QC, through which the 3-bit output will be displayed, and respective J and K, JB, KB, JC, KC will be connected as shown from the K-map expression. So coming to the circuit, if you can see, this is the trainer kit that we have used for conducting experiment of synchronous up counter, and we have used 7408 and two 7476 ICs in this slot, and we can see the lights glowing at the input side, which is preset and clear, and here it is the two inputs of JC, KC, and here we can see the outputs coming and going in a increasing up counter order. So this is 1, 2, 3, 4, 5 and again 0. 0, 1, 2, 3, 4 and 5. So this must be rotating automatically, and this will be done automatically because of the clock, TTL clock that we have provided here for 1 Hertz. So the clock input is given for 1 Hertz, and the counter will keeps on running until you turn off. So this is how the experiment is conducted for synchronous counter. Thank you one and all.